We are now going to look at how to do the z-test for the population proportion P using the critical value method. This is pretty much the same thing as using the critical value method for mu. Everything's going to be the same. Your rejection rules are going to be the same. Your z-crits are going to be the same. The only difference is here, where we have how we check our sample size and our test statistic. In this case, we need to take our sample size times our proportion and make sure it's greater than or equal to 5. We need to take our sample size times 1 minus our proportion and make sure it's greater than or equal to 5. And then our test statistic is done by this formula: p hat minus the initial p divided by the square root of the initial p minus 1 minus the initial p, all divided by n. That is a mouthful. Our z-crits are the same for a right-tailed, a left-tailed, and a two-tailed. Rejection rules are the same for a right-tailed, left-tailed, and a two-tailed. The Centers for Disease Control and Prevention reported in 2010 that 20% of Americans smoked tobacco. A random sample of N equals 400 Americans found 76 who smoked. We are interested in testing whether the population proportion of Americans who smoked has changed from 20%. Test whether the population proportion of Americans who smoke has changed from 20% using the critical value method and level of significance alpha 0.1. First thing we need to do is we need to check to see if our sample size is big enough. Black. So I take N times P0, which is the 0.2, so 400 times 0.2, and that gives me, so 400 times 0.2, and that is a total of 80. And then N times 1 minus P0, that is 400 times 0.8, which equals 320. So it's greater than 5. We could have also skipped this step and just took 400 minus 80, and we would get the 320, both of which are greater than or equal to 5. Our example here is actually going to be a left-tailed test. I need my pen. Black. So this is left-tailed. I'm not really going to touch on two-tailed because that's when it happens when they're not equal. You do have 1 or 2 examples in your work of two-tailed, but really everything's pretty much just going to be left-tailed or right-tailed. You use two-tailed when you don't know, really. It just says it's not equal. But for the most part, you're going to know whether you have an increase or a decrease. So this one, the Centers of Disease Control and Prevention reported in 2010 that 20% of Americans smoked. So that's our initial P is 0.2. Our N, because we have a random sample of 400, is 400. And our P hat is going to be the 76 out of the 400. And that equals 0.19. So we have a decrease. So this is left-tailed. And that we need to look up. We're doing alpha of significance 0.1. So our z-crit in a left-tailed is negative 1.28. Negative 1.28. We need to state the rejection rule. We're doing left-tailed, so z-data has to be less than or equal to z-crit. So now I know I didn't follow all those wonderful steps. HO, or in order I should say, I'm following all the steps, but they're not in order. That P0 is equal to 0.2. Our alternative is that P0 is less than 0.2. And now I need to calculate my z-data. I'm going to write down the formula. Z-data equals P hat minus P0 divided by the square root of p0 times 1 minus p0, all divided by n. Substituting, 0.19 minus 0.2 divided by 0.2 times 0.8 divided by 400. All right, so I put that all into the calculator, and I get our z data equaling negative 0.5. So negative 0.5 is unfortunately not less than or equal to negative 1.28. It's greater than. So we're going to reject HO. Okay, hopefully that sheds some light on the critical value method for population proportion, and there will be one more video explaining population proportion p-value method.